Here we're counting the more, if you want to say quote unquote, more advanced robot in the sense of, notice how we don't just have one arm, we have a combination of two arms. And what this is showing us is, think about it, it's more of a true arm in the sense of you've got the part that goes from the shoulder to the elbow as one part, and then you have another part that goes from the elbow to, let's say, the end of the hand. So now it's like I can now program my robot to raise its arm and then wave back and forth, okay? And again, always in all this programming, when you're trying to train a robot to do something, it's all built in as a microchip, because you're telling it, okay, rotate first of all the arm up through 20 degrees to this position. Let's say it's this, like 0.5 comma 0.6, and then once at that position, we're going to take the other arm and rotate it where it's now at that point all one arm. We're going to now pivot it, let's say an additional 45 degrees, okay? And that's what this whole part about is, realizing we not only have two arm lengths, but now we have two angle lengths. One angle telling you what to do with the first arm, and the second angle, after it's even gone, obviously that first angle, it's gone now a second angle in addition to it. And this is the most important part, is this second diagram that I have drawn here. Because you have, first of all, the first arm length going theta 1, but realizing that the second arm length up here, L2, also goes theta 1. It just goes in addition to that theta 2. Okay? And so that's very, 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 very important, because as we kind of change up our rules that we just did above, where typically x is equal to L cosine, theta, we're actually going to have to change that up a little bit, because we don't just have one theta anymore, and we don't just have one L. We've got a duplicate of them. Okay? So let's go back at this. And this is what this next part is telling you to do, is what to do when you have a two-part arm. Okay? X1, because you basically have two coordinates. I don't know if y'all noticed that before. You've got one coordinate right here, and you've got a second coordinate right there. So it's what to do, depending on what you're finding, okay? So the x value in the first coordinate is just our typical one, because this is our arm that we're used to seeing. And y1 is just the typical L1 times the sine of that angle. Now here's the new part. What to do about the second arm as it gets moving is to take the x value there is our L2. It's the cosine, though, of the sum of the two angles together. It's the angle it rotated with the first part of the arm plus its own new angle. And the same thing with to get to the second y value coordinate. You take that arm length, you rotate it at so many degrees with that first arm length, and then its own new angle for the second. Okay? And together, since we know basically if you want to get to the final x value and the final y value, you just add up the two other x values or the two other y values. And so this is just combining those two parts together into one big formula. Okay, so definitely we're going to reference this a lot in this next example. Okay, and then to start here in example 1, what I went ahead and did just real quick is I wrote out the formulas that we just had above on how to solve a two-arm robot. And so, x is a combination of theta 1 and theta 2, and then the y value for a combination of both arms, theta 1 and theta 2. Okay, so let's start out here with example A, and let's look into here. It's telling us our two angles. One angle is 90 degrees, so we're going to rotate up to 90 degrees. And then the second angle, we're going to rotate back 90 degrees. So first of all, we want to draw the picture, and then from that, we're going to get the final position of that last arm once it's finally resting. Okay? So if I give myself kind of like an XY axis so I can get started with, let's talk about the two-part rotation. We're going to do it in two colors here. Let's represent, let's say purple, let's represent the first part of the arm. And then, I don't know, let's say green for the second part of the arm. So the second part of the arm is going to start from there and go to there. Okay? So there's my two-part robot. Now the first thing says what we're going to do is we're going to take this arm and we're going to rotate it up 90 degrees. So obviously we're going now to the y-axis. So we're going to take all of this as one big unit and rotate it up, and that's theta 1. So now we're going to go up to here, and because the second arm is attached to it, then obviously the green portion has to go with it. We're going up to there. Okay? So that's me rotating that robot, first of all, through 90 degrees. Now what I want you to do is almost consider turning your head exactly to the left. Turn it sideways, because now we have to talk about what we're going to be doing with the second arm, because we've only rotated half of it. If you pretend like this second arm right here is now the positive x-axis, and I need to rotate it down 90 degrees. So all of this needs to come down a negative 90 degrees. So that'll be theta 2. So by the time I do that, then that arm is really sitting here just like that. Okay, so let me draw the overall picture as one final answer. So here's like your XY axis. The first part of the arm was rotated 90 degrees, so it's going straight up to here. And then the second part of the arm, when it was rotated negative 90 degrees, landed it right there. So that up to there was theta 1. And then going from here down to there, that was theta 2. So right there, that's our final coordinate. That's our final resting place. Okay, and so from here, we just need to get the final point. What's that coordinate? What is that P of XY? That's what we need to find. Okay. Well, I don't know my arm lengths, but so we're going to have them pretty much written in terms of L1 and L2. So what I know, let me kind of come down here for a second, is that X is equal to L1 times the cosine of theta 1. Well, theta 1 was 90 degrees. And then plus L2 times the cosine of the sum of the two. So 90 degrees plus a negative 90 degrees. Okay, well obviously 90 and negative 90 goes away and you just get 0. So what's the cosine of 0 though? Because you're not going to multiply 0 times L2. It's because you have to take the cosine of 0. Okay, so X is equal to L1 times the cosine of 90. Well, the cosine of 90 degrees is all of that is 0. So L1 times 0, and then L2 times the cosine of 0 degrees, which is actually 1. So I know that the x coordinate is really equal to L2. So whatever the arm length was for the second part of the arm, that's actually where that's the x value of your coordinate. Okay, let's do the same thing with y. Okay, y is equal to L1 times the sine of theta 1 and plus L2 times the sine of theta 1 and theta 2, which we decided was 0 degrees. Okay, well the sine of 0 degrees, all of that 0. The sine of 90 degrees is 1. So this is saying y is equal to L1 times 1 plus L2 times 0. That knocks that portion away. So y is equal to the first arm length. So really, for a final answer then, my final coordinate, if I want to write it up here, is P of xy is equal to the x value is L2 and the y value is L1. So it just happens to be those exact arm lengths, just like that. Okay, so let's try this again with part B. Okay, so for part B, we've got, again, let's draw ourselves this picture. Give myself kind of the XY axis to get started with. And let's get ourselves a two-part robot. We have one part of the arm from there to there, and the second part just getting started, as you know, is just right attached with it. Okay, so it's telling us that first of all, we want to rotate all of this as one big unit up 45 degrees. So we're just going to go up just 45 degrees, or theta 1, and that's going to take that arm to right there. And because it's connected as one big unit, so far we're looking at it like that. Okay, now to finish this up though. Consider this now the x-axis, the second arm, okay? It's like there's the x, and we want to rotate this now down a negative 45 degrees. So now that's going to land that just right there. Okay, so if we put these together as one big graph, then theta 1 takes the arm up to here, both parts, but then theta 2 knocks the second part down a negative 45. So there is theta 1, and there is theta 2. And there's our final point, P of xy. Okay, so we want to find the coordinate of that very last part right there. And we're just going to, again, we don't know what the lengths of the two arms are, so our answers, the coordinate itself is going to be in terms of L1 and L2. Okay, so let's come down here and let's start it out. So x is equal to L1 times the cosine of theta 1, which was 45 degrees, and then plus L2 times the cosine of the sum of the two, so 45 and a negative 45 degrees. So x is equal to L1 times the cosine of 45 degrees, which is the square root of 2 over 2, and then L2 times the cosine of 0 degrees. Well, if we come down here, cosine of 0 degrees is 1. So we have basically x1 to be square root of 2 over 2 L1 plus L2. And I'm probably honestly going to leave it just like that, just in terms of those, because I can't combine L1 and L2 because they're not like terms. Okay, so let's try with the y. So the y is L1 times the sine of the first angle, which was 45-degree rotation, and then L2 times sine of the sum of the two, which we saw was 0 degrees. Okay, well the y value at 0 degrees is actually 0. So this is saying y is equal to L1 times the square root of 2 over 2 plus L2 times 0, wiping all that away. So y is equal to the square root of 2 over 2 L1. Okay, so if we put these together into one coordinate, then I know my overall coordinate, that last resting place right there, is the x value is a little large, but it's square root of 2 over 2 L1 plus L2, comma, and here's the y value, square root of 2 over 2 L1. So all I have to do to really find the true coordinate is they just have to give me what the lengths of the arms are. I plug them into here, into this formula we just got, and that's going to tell me my coordinate every single time. Like specifically when theta 1 was 45 degrees and theta 2 was a negative 45 degrees. Okay, well, let's keep going on.